Subchapter 4.2 The Carnot cycle. For your information, vapor-powered cycles covered in this chapter is a heat engine based on the Carnot cycle. The Carnot cycle is the most efficient cycle, operates at two specified temperature limits. The Carnot cycle composed of 4 reversible processes. These 4 reversible processes consist of 2 isothermal processes and 2 adiabatic processes. Originally, in Carnot cycle, the device used is compressor instead of pump. For process 1 to 2, it is isentropic compression in compressor. Process 2 to 3 is isothermal process heat addition in a boiler. For process 3 to 4, it is isentropic expansion in turbine. And process 4 to 1 is isothermal heat rejection in condenser. In our previous discussion, we know that thermal efficiency of a cycle can be given by this expression. Since in Carnot cycle, we know that the temperature for the heat sink is equal to TL and the temperature for the heat source is given by TH, the thermal efficiency of the Carnot cycle can become this expression. If we have a look at this TS diagram for Carnot cycle, at state 1, the substance is in mixture phase. At state 2, the substance is in saturated liquid phase. For process 2 to 3, it is isothermal heat addition from saturated liquid to saturated vapor phase. Process 3 to 4 is isentropic expansion in turbine. At state 4, the substance is in mixture phase. And process 4 to 1 is isothermal heat rejection in the condenser. Although we know the Carnot cycle is the most efficient cycle, however, it has several impracticalities. For example, process 1 to 2 in compressor, it is not practical to design a compressor that handles 2 phases of substance. For process 3 to 4, the turbine cannot handle steam with a high moisture content, which is low quality steam. The moisture can cause corrosion and wear the turbine blades. Therefore, these impracticalities should be eliminated by condensing the steam completely in the condenser and superheat the steam in the boiler. Now, the process in our compressor or pump and in our turbine will be in one phase. Note that by condensing the steam completely in the condenser and superheat the steam in the boiler, we are not going to have isothermal process across the boiler and the condenser, but instead the process across the boiler and condenser will be in constant pressure.